good turnout. My name is Paul Roberts. I'm Technical Services Manager for a small company called Tuscany Networks, and I'm here today to talk to you about DNS best practices. So let's just see if this works. There we go. So some of you may have heard of us. Probably a lot of you probably haven't, to be honest. We've actually been in this market for over 12 years now, and we're a specialist solutions integrator that is involved with IP address management, DNS, DHCP, all these kinds of solutions. We're also involved with some network discovery tools that help you identify all your switch ports and switch port wastage. So, we've got quite a large customer base, many large FTSE 100, FTSE 250 companies, a lot of smaller companies as well. So we've got a really good pedigree in the marketplace for the sort of work that we do. So there's probably a fair few of you probably know what DNS actually is. There might be some people that don't. So I'm going to go right back to basics, start off nice and simple, and just talk about what exactly is this DNS thing that I talk about. And it's really all to do with IP addressing at the end of the day. Obviously, everything that connects to the network nowadays has an IP address. Incredibly difficult to remember all these numbers. So it's human nature just to give everything a name. But somehow we need to translate that name into an IP address. And that's really where DNS comes from. It's a translation service. So you can think of it as a telephone directory. So if you think of all those TV adverts, for all those big well-known brands out there, they're all advertising their website. You think, oh, directline.com. I bet you don't know the IP address. So you type in directline.com into your browser. Your browser will go off onto the internet, contact a DNS server, and actually convert that web address into an IP address. Your browser can then contact that server and you get served the page. So obviously there's a few examples there where if we didn't have DNS, all these big brands would be using IP addresses or some other magic service. And obviously you can use DNS internally as well on your internal network. So it works both internally and externally. DNS actually stands for the domain name system. So basically you have various servers on your internal network that run the DNS service. And these provide the translation for your internal systems. So if you need to contact your Note server or your Exchange server, you'll do it by a name. That name obviously gets translated using DNS. So your clients will be querying these DNS servers in your internal network on a constant, regular basis. And they're basically critical to the operation of your network. So typically what's happening is your PC's just going off to a local DNS server, sending it the name that it wants to look up, and you get back an IP address. It's dead simple. Now there's a lot of applications out on the network and in your environment that are totally reliant on DNS nowadays. One of the biggest ones is Active Directory. Everybody's running Active Directory nowadays, totally reliant on DNS. Your email system's totally reliant on DNS. File and print, again, totally reliant. All your internal systems, such as Oracle, SAP, ERP, all these kinds of systems, totally reliant on DNS. So you can see that DNS is fundamental to the core of your network. It's a fundamental part of the infrastructure. And if you suffer a DNS failure, you'll quite quickly start suffering from additional problems within your network. Now, one of the problems with DNS is it doesn't generally get much visibility. You tend to find that IT departments spend lots and lots of money on their core network infrastructure, on their SAN, their storage solutions, Microsoft or their Active Directory environment. DNS just sits there in the background, just working, doing its stuff, until something happens, and if it goes wrong, that's when you really notice. So DNS typically gets neglected. It just tends to sit there doing its job. There's a whole bunch of other services, as well as DNS, that kind of form this category that we call core network services. And they've all typically suffered from underinvestment over the years. So what we've got here is, in the middle, what we've got is this kind of layer called core network services. And you can see there's some other services that fit in that area. Things like DHCP, for instance, which is obviously used to issue IP addresses to all your hosts. Things like TFTP and HTTP, which are used to boot your voice over IP phones. radius authentication, and also time. Time is a very important service on your network, and that's normally provided using NTP. So these are all services that your network is totally reliant on, but are generally kind of tucked away and hidden, and they just sit there working. And because of that, you normally have some problems with the responsibility for managing and supporting these services. So at the top, for instance, you'll have all your applications, and you'll normally have your application support teams responsible for supporting these applications. And at the bottom, you'll have your network architecture, your infrastructure. So you'll have all your Cisco guys, all your CCIEs, and all your firewall guys, and all your security people. And then all this core network stuff, it's kind of like it falls between the cracks, because the network guys don't typically want to do it, because they're interested in Cisco kit and getting their certifications. And the application guys aren't interested either. They just want something that works, that they can build on. So I've been to quite a few companies where this kind of whole area tends to fall between the cracks, and it kind of ends up in the lap of like one or two people. Now I've got a couple of stories here. Both of these were actually financial institutions, going back a few years now. But basically, I turned up at a financial institution, and they were running an old NT network with Wins, and they needed to roll out DNS. So they put the old Windows NT DNS server, I think it was Service Pack 3, I think it came out, and it just sat there on someone's PC. But obviously, as the environment grew, more and more applications got introduced to the network. They became more and more reliant on this single DNS box that was running on someone's PC under their desk. Now, we've actually gone in and replaced it now with a more resilient infrastructure. But it is very typical of the sort of things that we see. Another one just recently, they downloaded Bind off the internet, installed it on a Linux box. And again, we're in this situation where there was a Linux box, and only one person actually knew anything about this DNS server. And just this week, we've been working with yet another large financial institution who've been suffering some chronic DNS problems. Just over the last few days, actually, their entire infrastructure was taken out by a server that crashed from some corruption. So again, we're already in there working on deploying a more resilient infrastructure. Now, obviously, a lot of you have probably rolled out Active Directory. It's fundamental to Windows operating systems. Active Directory gives you a perfectly reasonable and solid DNS server. So you'll end up with DNS running on your network regardless, whether you like it or not, because AD installs it by default. But some of the questions you have to ask yourself are whether those AD guys are suitably trained, because DNS is quite an expansive topic all by itself. We run training courses in our facility. We run a 3-day pretty intense training course just on DNS. So the AD guys, although they may be AD experts, they certainly probably won't be DNS experts. So if you have a DNS issue, you could be reliant on your AD guys. And also, a DNS failure can bring down AD. If your DNS is running on AD and AD goes down, then that can take out DNS. You've got this chicken and egg. And you will probably have other systems totally reliant on those DNS servers, and they'd be Unix boxes and mainframes, your production systems. So you might have to start asking yourself some questions about whether you really want your production and operational systems to be running off a Microsoft box that the AD guys are in control of. And Microsoft themselves have previously stated that 70% of all AD and Exchange calls were in fact DNS related. And that's because DNS is a complex topic and it can be difficult to set up. So what I'm trying to highlight here is that although you can get DNS up and running very simply, when you start expanding the network and getting to more complex environments, it can be quite critical, very critical to the network.